This is Module 4, Lesson 9. What is slope? We're actually going to look at slope, and we're going to look at how to use what we learned here in writing linear equations. So how does all this fit in? This is standard 8EEB6, where we're going to derive the equation y is equal to mx for a line through the origin, and the equation y is equal to mx plus b for a line that intercepts the y-axis at b, okay? We'll talk more about this. We're mainly concerned about this y is equal to mx equation right here, which is what we have actually been doing. Now, today we're going to determine the slope from graphs of linear equations. This is going to be from the packet. If you received a paper packet from the school itself, Module 4 paper packet 1, then this is on page 2 and 3, or maybe packet 2, page 2 and 3. Okay? Most everybody will have this also available under the resources of OnCourse. It shows up as Module 4 packet. Now, let's start talking about what is slope. Slope. It is the constant rate of change between points on a line. We've been using this rate of change. We've talked about rate of change. Let's think of other things that we've called it. We've called it rate of change. When we have a denominator of 1, we call it unit rate. Okay, now we're going to talk about it as slope. All of these things refer basically to the same thing. The unit rate is when your denominator is 1. When you say something like 50 miles per 1 hour, instead of saying 100 miles per 2 hours. 100 miles per 2 hours is the rate of change. When I make the denominator 1, so it's 50 miles per 1 hour, and it's a unit rate. The slope is exactly what we're talking about, that the rate of change. When we plot it, it gives us a slope. Okay, so the constant rate of change between points on a line is the same thing as known as a slope. Okay, we can call it slope, we can call it rate of change. The variable you're going to see is m. The equation looks like this for a line. Y is equal to mx plus b, and that's when you're talking about a line that goes through the y-axis at some point b. This would be at point 0b. Okay, that's what that line looks like. What if b is 0? What if we're looking at a line, a straight line? I can't draw worth a darn, but a straight line that goes through 0, 0. If your b is 0, 0, then your equation is simply y is equal to mx. In both cases, this m is your slope, your rate of change, okay? And it can give you a lot of information when you're plotting stuff. Now we're just going to talk about it as a number to make sure you can find it when you are looking at a plot. When your line goes up like this, see how the little skiers going up? This is a positive slope. That means it is going up. Whenever the line goes down, this is called a negative slope. What if the line is horizontal? I mean, this little skier is not moving at all. Your slope is 0. And what if your line's going straight up and down? Well, there's nothing to hang on to there, right? This slope is what we call undefined. Okay? Now, we'll get back to those as we go. Finding slope given a graph. Slope is equal to what we call rise over run. How far up you go on the y-axis versus how far over you go on the y. The y-axis is the rise, it's the up and down. So slope is also equal to your change in y, change in your y values, over your run would be your change in your x values, okay? Slope is rise over run, which is change in y over change in x. Now, it's pretty easy to find slope on something like this. You find 2 points that are obviously on the grid lines. Look how this point's not on where 2 grid lines meet, right? That point's not. But this point is, it's where 2 grid lines meet. To find the slope here, I'd find this point, then I'd find another one that's obviously on the grid lines. They've given you a dot on this, so it makes it easier. To find the slope, the m, is rise over run, which is change in y over change in x. Same thing, right? Rise over run. Okay, so what you do is you're going to draw a right triangle. Let's draw us a right triangle along these grid lines. See, I'm going up and over. Remember when we were talking about translating points? What if I were translating this point from here to here? What would I be doing? I would be going up 1, 2, 3, 4, 5, 6, 7. So I went up 7. That's a change in y. See, along this y-axis, I'm going up 7. So it's a positive 7. How far am I going on the x-axis, in which direction? We know if I'm going on an x-axis, this is the positive and this is the negative. I would go over 1, 2, 3, 4. That's 4 in the positive direction. The slope for this particular thing is 7 over 4. So it's a positive slope. The line is going up. That makes sense. Positive. What this tells me is I go up 7 units for every 4 that I go over. A lot of times they use this to talk about the steepness of something. What if you're talking about the steepness of a roof? You'd be going up 7 feet for every 4 feet that you go over. Okay, now let's look at this second one here. Okay, the first thing I'm going to look at is I'm going to say I know what I'm looking at is rise over run. But in this case, guys, notice how this line is going down. I know my slope is going to be negative. As I read this like I would a page in a book from left to right, this is going down. So we know my slope is going to be negative. Again, m is equal to rise over run, which is change in y over change in x. We're going to find 2 points that are definitely on grid lines. We're going to draw a right triangle between them, and we're going to figure out their rise over their run. Okay? They've marked 2 points for us that are on grid lines. Okay? So let's take those two. If I draw a right triangle, let's see, from here to here, then it makes it easy for me to do my rise over my run. Rise is whether I'm going up or down. In this case, I'm going down, so it's negative rise. And think of it, if you're on your y-axis, you are going down 1, 2, 3. So I went down 3. And on the x-axis, I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 3, and in the positive direction on the x-axis, 9. Now, is that as simple as it gets? No, it's not, is it? Couldn't I simplify this? What if I divided this by 3 over 3? Wouldn't that give me negative 1 over 3? Well, let's look and see. I want to see if that slope works. Down 1 and over 3. Let's see if that'll get me to a grid line. Down 1 over 3. Oh, yeah, it does. Look, guys, can I do that again? Down 1 over 3. Yeah, look. In each case, I could have done it this way. I could have gone down 1 and over 1, 2, 3. See, down 1 and over 3. It's the same slope no matter where you measure it, right? Look, down 1 and over 3, down 1 and over 3. Any of those would have worked. Our slope on this one is negative 1 over 3. That means I go down 1 and in the positive direction 3 for each one of these, right? Slope here is negative 1/3. M is equal to negative 1/3. Okay. Now let's try this one. Pick 2 points on the line that it's showing us, any 2 points. Okay. Here's the line they're showing us, and they gave us these 2 points. Well, we know that slope is rise over run, change in y. This is your y-axis over here, changing your x. Well, how many am I going up to get from here to here? I'm not going up any, am I? I'm going up 0, and I'm going in the positive direction on the x-axis 1. 0 over 1 is 0. My slope is simply 0. Isn't that what we talked about when we were looking at this one up here? We said our slope was 0, didn't we? Okay. If it was a horizontal line, that slope is 0. Just like on this one, if it went up, the slope's positive. If it goes down, the slope is negative. Look at number 4. Let's find the slope here. Okay, they gave us 2 points. Now we know that our slope is rise over run, which is the change in y over the change in x. Let's get on our y-axis here. What am I doing? I'm going up 1, 2, 3, up 3. And on my x-axis, I'm not going over any. 3 over 0. 3 divided by 0. If you have a calculator, put that into your calculator. 3 divided by 0. And what you're going to see is something like error or, does not work or something to that effect. Because you can never divide anything by 0. Up here, when 0 is on the top, you can divide 0 by 1, but you can't divide a number by 0. If 0 is in the denominator, guys, it doesn't work. Therefore, it is undefined slope. Just as we talked about right up here, it showed you if the line is vertical, the slope is undefined. Okay? And if you're not sure, put that in your calculator, guys, and it makes it very simple for you to see. Okay, let's try this one. Let's find the slope here. They gave us 2 points we could use. Look, they gave us 2 little dots we could use. Remember, our slope is rise over run, which means change up and down on the y-axis over change left and right on the x-axis. The y goes on the top. So we do the y first, rise. We're going to go up 1, 2, 3, 4, 5. We go up 5 and then over 1, 2, 3. My slope is 5 over 3. It's positive because it's going up, isn't it? Okay. Let's try this one. Let's take these 2 points and let's find our slope between them. See, it's going up. It's going to be positive. On the y-axis, rise over run. We're going up 2 and over 2. Okay, if you go up 2 and over 2, can't you just simplify that? Wouldn't you wind up with 1 over 1? Okay, up 1 over 1. Let's see if that works. If I went up 1 over 1, I'd wind up with a point that's on the line, wouldn't I? Up 1 over 1, I wind up with a point that's on the line. What is 1 over 1? 1 divided by 1 is just simply 1, right? So if your slope is 1, it's the same as 1 over 1, right? Or 2 over 2, 3 over 4, 3, 4 over 4. In this case, your slope is 1. It's positive. It's going up. Okay. The next page. Let's look at those. Let's find the slope on this one. We know the slope is negative because it's going down. We've talked about our slope. It's rise over run, or the change in y over change in x. I'm going to write this here. Rise over run. Same thing as change in y over the change in x. Up and down versus left and right. Okay? So here's our 2 points. Let's draw our right triangle here. What am I doing? I'm going down 1, 2, 3, down 3, and over in the positive direction 1. My slope is negative 3 over 1, or you could just say that's negative 3, isn't it? Okay, so the slope on this one is negative 3. Let's try the slope on this one. It's going up, should be a positive slope. Here's 2 points they've given me because they're both on grid lines. Remember, our slope is rise over run. Change in y, here's your y-axis, over the change in x. So we go up or down first. This goes 1, 2, 3, 4. I went up 4 and over, let's see, 1, 2, 3, 4, 5. Up 4 over 5. My slope is a positive 4 over 5. I went up 4 and over 5, didn't I? Okay. Now let's try this one. Oh, horizontal line. If you can't remember, it's rise over run. Remember, pick 2 points, any 2 points on here. I'm not going up any to get to that, am I? Rise is 0. Run is 2. 0 over 2 is equal to 0. Put that in your calculator to make sure. If you say 0 divided by 2, it's going to give you 0. It's not going to say undefined or it doesn't work or you made a big mistake or something like that. Okay, so this slope is 0. Horizontal lines have a slope of 0. You're not slanting in either direction. Okay, now let's look at this one. This one's going up as I read from left to right. It's going to be a positive slope. Remember, our slope is rise over run, change in y over change in x. So I go up or down first, right? I do my rise first. To get from that point to this one, 1, 2, 3. Let's see. 1, 2, 3, 4. I'm going up 4. And I'm going in the positive direction 2. 4 over 2. Can I reduce that? How about if I take 2 out of each one? Wouldn't that give me 2 over 1? And 2 divided by 1 is simply 2, okay? Let's see if the slope of 2 would work. 2 would be up 2 and over 1. Yeah, look at that, guys. You could have done it that way too, because that's on a grid line. Then you do up 2 and over 1. Gives you the same thing, doesn't it? Okay, my slope is 2. For each 2 I go up, I go over 1. That's what it tells me. Now let's look at this one. I'm going up 1 and over 1, 2, 3. My slope is 1 over 3. Notice the bigger the slope is, the steeper the line is. This slope is 2. It's pretty steep. This slope is 1/3. It's not as steep, is it? We know it's positive because as you go from left to right, the line's going up. Okay, what do we remember about a vertical line? Well, if we don't remember, let's choose 2 points that are on grid lines and let's do our rise over our run. In this case, we're going up 1, 2, 3, up 3, and we aren't going over any, so it's 3 divided by 0. Put that in your calculator, and it's going to tell you you made a mistake. Hence, this is undefined. The slope of any vertical line is undefined. Number 13, let's find the slope here. Remember, it's rise over run. Change in y over change in x. Okay, so I'm going up 1, up 1, 2, 3, 4, and over 1. Up 4 and over 1. Its slope is 4. 4 divided by 1 is just 4. That means for each 4 you go up, you go over 1. See, this one's very steep. It's steeper than the one that was 2. Okay, it only went up 2 for over 1 each. It's steeper than 1/3 because you go up 1 and over 3, okay? The bigger the number, the more steep the slope. Now let's try this one here. Remember, slope is rise over run. Up 2, over 1, 2, 3. Up 2, over 3. There's your slope, okay? I can't reduce that one. And it's positive because it's going up. This one's going down, so its slope is negative. Remember, rise over run. We're going down 1, 2, 3, 4, 5. Down 5 and over 1. Down 5 and over 1. That's negative 5 over 1. If you divide anything by 1, you don't change it. That slope is simply negative 5, which means every time we go down 5, we go over 1. Okay? And the slope is negative. See how the line's going down? And we knew that because we go from here to here. You got it. You're going to ask, well, what if I went up here? If I went up here, guys, look, you get the same thing. You'd go up 5, but back 1. Look at that. That would be up 5, but back 1, which is still negative 5, isn't it? Okay, so you get the same thing no matter which direction you go on your points. Okay, on these two, I'm going up 1 and over 1, 2, 3, 4. My slope is 1 over 4, up 1 over 4. This is also positive. Let's see what our slope is. Rise over run. Changing y over changing x. Up 1, 2, 3, 4, and over 2. Up 4 and over 2. Okay, in the positive direction 2. Now, can I reduce that? If I reduce that by 2 over 2, wouldn't I wind up with 2 over 1, which is 2? My slope is 2, isn't it? Let's see. If I went up 2 and over 1, yep, I'd wind up right there. If I went up 2 and over 1, I'd be right on top of the thing again, wouldn't I? My slope is 2. We know the slope is negative here because it's going down. Rise over run. So we do our y first. We're going down 1, 2, 3, 4. I went down 4. And then I'm going over 1, 2, 3, 4. Down 4, over 4. Negative 4 divided by 4 gives me negative 1. My slope is negative 1. That would be, I'm going down 1, over 1. Yep, it's on the grid line. Down 1, over 1. Yep. Down 1, over 1. Down 1, over 1. Okay? Your slope is negative 1. How about 19? Let's see what we get going from here to here. You're going down 1, 2, 3. Down 3. And you're going over 1, 2, 3, 4. Down 3 and over 4. My slope is negative 3/4. This one's going down, so we know it's negative. But look, guys, even here, you're going down 1, 2. So I went down 2, and I'm going in the positive direction. 1, 2, 3, 4. Negative 2 over 4. Can I reduce that? How about if I divide that by 2 over 2? When I get negative 1/2, for each 1 I go down, I go over 2. Down 1, over 2. Down 1, over 2. Okay, this just basically tells you the same things you would know if you were translating it. And then this one, from here to here. Remember, slope is rise over run. So I go up 1, 2, 3, 4, 5. I go up 5 and I go over 2. Up 5 and over 2. My slope is 5 over 2. Okay, that covers all the finding slopes for each one of those. I want you to see some things about linear equations themselves. I told you that a linear equation looks like y is equal to mx plus b. M is our slope. Now remember, that's what we just started calculating, guys. All these slopes were what we were calculating. We were calculating the m in this linear equation. The b is your y-intercept, where it intercepts the y-axis, where it crosses it, okay? You see this one right here where it crosses at the origin, 0, 0. If it crosses at the origin, your linear equation is y is equal to mx. So if this is your m, your linear equation is simply y is equal to 1/3 times x. Okay, if your b crosses somewhere else, like C, let's find one where it crosses at a definite point. Here, this crosses at negative 1, 2, 3. Okay, you start with y is equal to mx plus b. If your m is 2/3, y is equal to, all you have to do is plug in the m, 2/3 x, and where is this? Negative 1, 2, 3, plus negative 3. Now, we're going to talk more about that. The main reason I wanted you to see this is because I want you to realize that all the stuff we were doing earlier where we were writing linear equations, remember this example? Water flows at a constant rate out of a faucet. Suppose the volume of water that comes out in 3 minutes is 10.5 gallons. We did this a couple of lessons ago. Okay, and they wanted you to write a linear equation. Well, we wrote it by setting up our rate. We said it was our m, our rate of change. It was 10.5 gallons per 3 minutes, right? And then we changed that. We reduced that to a unit rate. We divided 10.5 by 3. We said that was 3.5 gallons per 1 minute, right? Okay. Well, and then we wrote our linear equation, right? We had our y was equal to our volume in this case. Volume was equal to, here's our m, 3.5 times our time. Okay, we wrote that. See, remember it's right here. What if we did it straight from this thing here? Remember we talked about y is equal to mx. M is our slope. Let's look down here. On our y-axis is our v. On our x-axis is our t. All I need is this slope, this m. Well, we just did this just a minute ago on all of those. What we did is we found 2 points that were on grid lines. What if I took this point here at 0, 0, and let's see another one that's definitely on a grid line right there. Isn't that where the 2 grids meet? Okay. Let's do our right triangle. Remember, our slope is equal to change in y over change in x, which is rise over run. Let's see if we can find our m for this equation without having to go through all of this other stuff. Let's see if we can just simply find it by doing rise over run. Well, let's look. On the y-axis, we are going up 7, and over what? 2, up 7 over 2. My slope is equal to 7 over 2. Could I divide that? What is 7 divided by 2? 7 divided by 2 would give me 3.5, wouldn't it? My slope is 3.5. Volume is equal to 3.5 times t. So see, we can get the slope either by going through the word problem and figuring it out, or we can get it by using rise over run on our graph. Okay? We have created the exact same formula we did on here, simply by looking at the graph and finding the slope, the rise over the run. Let's try the same thing with one other that we did. Okay, this one was the one about constant rates. It says Pauline mows a lawn at a constant rate. Suppose she mows 35 square feet in 2.5 minutes. Okay, now we had to write an equation from that, and we went through a lot to get there, didn't we? To get y is equal to 14t. Okay, there was our equation. The area in square feet is equal to 14 square feet per minute times the time. Can I do that just by using this? Y is equal to mx. Okay, now all I need to do is find the m. The x is called t. My x-axis is called t. My y is called y. How do I find my m? Remember, it's rise over run. Okay, so let's start here. And let's go up to one of these points. So this point, even though it doesn't show it on being on grid line, I know this point, this is 14 right there, isn't it? So that's 14, okay? So if I go up, I'm going up 14, okay? Up 14. And over how many? Over 1. The slope is 14 over 1. So y is equal to 14 times t. I got to the same equation simply by doing rise over run. Okay, guys, if you have a graph, you can use rise over run to find your slope and not have to do all the work that we had to do up here to get it. Okay? Now, we will use that some more in some of the other things that we're doing. I just wanted to make sure that you saw that there was another way to get to finding your slope. We can read it off the graph using rise over run.